Question 12d. A function is defined by f of x equals 4 minus 1 minus x over 2 all squared for x in the domain x less than or equal to 2. Part 1. Sketch the graph of y equals f of x, showing the x and y intercepts. The graph is a concave down parabola with vertex at 2, 4 in the domain x less than or equal to 2. Now the vertex can be read directly since the function is in completed square form. To find the y-intercept, we let x equal 0. So f of 0 is equal to 4 minus 1 minus 0 over 2 all squared, and that equals 3. To find the x-intercept, we let f of x or y equal 0 and solve for x. So we form the quadratic equation 4 minus 1 minus x over 2 all squared equals 0. Subtracting 4 from both sides and multiplying both sides by -1, so it does 2 steps in one, we have 1 minus x over 2 all squared is equal to 4. Taking the square root of both sides, we have 1 minus x over 2 is equal to plus or minus 2. Subtracting 1 from both sides, we have negative x over 2 is equal to -1 plus or minus 2, which corresponds to -3 or 1. And multiplying both sides by -2, we have x is equal to -2 or 6. But the domain of x is x less than or equal to 2. So we're only going to accept one of these answers. Hence the x-intercept is -2. And here's the graph of y equals f of x. And I've shown here the x-intercept, the y-intercept, and also the vertex, even though the question doesn't ask for that. And it's also important to note that the range is y less than or equal to 4, and that'll be used in a subsequent part. Part 2. Find the equation of the inverse function, f inverse of x, and state its domain. To help make finding the inverse function a little easier, we can replace f of x with y in the function. So it can be written as y equals 4 minus 1 minus x over 2 all squared. Then we transpose or swap the x and y variables. So it becomes x equals 4 minus 1 minus y over 2 all squared. And then we make y the subject of the formula. So subtracting 4 from both sides and then swapping both sides of the equation around, we have -1 minus y over 2 all squared is equal to x minus 4, because we want the y on the left-hand side and the x on the right-hand side. Multiplying both sides by -1, we have 1 minus y over 2 all squared is equal to 4 minus x. And taking the square root of both sides, we have 1 minus y over 2 is equal to the positive square root of 4 minus x. Now note that the positive square root is needed since the point 3, 0 must lie on the graph of y equals f inverse of x. Since on the original graph, it passes through a y-intercept of 3, that means on the graph of the inverse, it must pass through an x-intercept of 3. And if we have the negative square root, then that point will not be on the graph. So from this line here, if we multiply both sides by -1 to make y positive, we have y over 2 minus 1 is equal to the negative square root of 4 minus x. Adding 1 to both sides, we have y over 2 is equal to 1 minus the square root of 4 minus x. And multiplying both sides by 2, we get y is equal to 2 minus 2 square root of 4 minus x. And then we can replace y with f inverse of x. Hence, f inverse of x is equal to 2 minus 2 square root of 4 minus x. And from part 1, the range of y equals f of x is y less than or equal to 4. Hence, the domain of y equals inverse f of x is x less than or equal to 4. So the domain and range get swapped around. Part 3. Sketch the graph of y equals f inverse of x. The graph of y equals inverse f of x is a reflection of the graph of y equals f of x in the line y equals x. Now the points 2, 4, 0, 3 and -2, 0 lie on y equals f of x. Swapping the coordinates around, 4, 2, 3, 0, and 0, -2 lie on y equals inverse f of x. So noting that, here is a sketch of the graph of y equals inverse f of x with the points 4, 2, 3, 0, and 0, -2 noted on the graph.